One of the problems pertinent to the data link layer is allowing access to the resources to multiple users. We refer to this as multiple access. In fact, this multiple access can be performed at the frame level, so it can be performed at the data link layer. And it might imply coordination which is handled by a central entity, but much more often is done in a distributed manner, meaning that the equipment which share the resources notify one another when they need to use the physical resources of the medium to transmit the data. In these cases, when we are handling what we refer to as random multiple access, from the point of view of the data link layer, we subdivide it in two sublayers. So in the MAC and the LLC, the MAC stands for the medium access control, and the LLC stands for the logical link control. While the logical link control manages other typical functionalities that we've covered before of the data link layer, the MAC, so the medium access control, is what handles the multiple access of the physical resources by multiple users. One of the scenarios in which we might need or we apply random multiple access is a case in which we have two transmission stations, a blue one and a red one, which are transmitting at the same time. If they transmit at the same time, then there is a collision that happens. One of the simplest way how we can avoid this from happening is initializing a random time after which each of the stations starts the retransmission. This random time is local and is local to each of the stations. So after a certain amount of time, which of course are predefined according to the protocols that are in place, the blue station starts to retransmit. And since the retransmission happens after a random time, it's very likely that the times will not match, and therefore we are avoiding having a collision. One of the protocols that implies this type of mechanism is the Aloha protocol, which is actually the protocol of the first local network, AlohaNet, that we've mentioned before. The idea is that when station A and station B are transmitting at the same time, there might be a collision. So if station A waits for a random amount of time and station B waits for a random amount of time, then it is possible that each of these stations is able to transmit without having to deal with a collision. However, this protocol could make sense in case we are dealing with a single station that is transmitting. However, if we are dealing with multiple stations, this might be a problem, because if we employ multiplexing in time, for example, so we have defined previously TDMA as time division multiple access, and you allocate a time slot to different station, in this case we would have 5, then if the station which has been allocated the first frame transmits only when it's his turn or their turn, then we have a lot of resources which are not used in a very optimal way. There are also other ways which can be actually shown that having a large number of users actually shows that the probability of collision will rise significantly. In fact, Aloha has several drawbacks, because the main idea is that by just randomly resetting the time for which you transmit is not sufficient to avoid collisions. It is also important to also put in place mechanisms that check if the channel that you intend to use is free, is available, And we will call this or refer to this as listening before talking. Basically, the idea would be that you check whether the channel that you intend to use is available, and in case it is available, then you would occupy the resources that you intend. However, does this mean that there are, in fact, no collision if you just listen to see if the channel is being used or not? In fact, no, because there is the communication that happens is not synchronous. So even though a channel might be listening to see if the physical medium is occupied or no, it is possible that there is a certain delay until the information arrives from another station that also intends to use those physical media. So let's look at an example of what I mean. The idea here would be that in case, so considering three stations, A, B, and C, in this case, A and B want to transmit information towards C. It is possible that the B station will start transmission towards C before it has received the information that A is also transmitting. So since there is some propagation delay between A and B, from the point of view of station B, the channel seems to be free. So B initiates the transmission towards C, and in fact only later on, once the transmission is proceeding, the B station will receive the information from A that in fact it has intended to use the channel. Therefore, it is possible to still have collision even in such a scenario. Or in this case, B intends to transmit, so it lets know both A and C that it intends to use the channel which is shared by all, or the medium, the transmission medium which is shared by all. However, by the time that the information for requesting the use of the physical medium has reached channel A might have already started the transmission towards channel C. So there is a need not only for checking whether the transmission medium is being used or no, but there is a need for additional mechanisms that also check whether the physical medium shared for transmission is available or not. In fact, we say that considering this mechanism, there is a vulnerability period which is defined with this delay tau, and here by tau we refer to the propagation delay between the two different stations, and it's actually due to the physical media which is used for this transmission. And we also define an efficiency of the mechanism used for the transmission, which we call A, and is basically the ratio between the propagation delay tau and the time to transmit the information, which in this case is t. And depending on the value of the A, if A is higher than 1 or significantly less than 1, then we say that the efficiency of the carrier sense multiple access might be high or not. The whole idea of the carrier sense multiple access is to put in place mechanisms that allow to sense whether the transmission media is in use in order to then proceed with the transmission of the data that need to be transmitted.